Okay, so this one is on partial differentiation, and this is also in the OCR A levels. And so this one is a very basic one. Once you learn what partial differentiation is and like the 3D functions, the saddle points, all that basic knowledge, you'll be able to handle this with ease. So part A wants us to determine the Hessian matrix. So we need the second derivatives, the partial derivatives, of course. So we'll need the first order derivatives. So that's just sine y plus minus y over x squared. Also dz dy should be a delta, by the way, is x cosine y plus 1 over x. And delta squared z delta x squared is negative 2, that should be just 2y over x cubed. Delta x delta y of delta square z, we get cosine y minus 1 over x squared. Delta y delta x delta squared z, we get cosine y minus 1 over x squared as well, which means this is a convex continuous function. And then delta squared, not y, dang it, delta squared z delta y squared, we get negative x sine y and nothing else. So now we have the Hessian matrix H. Do we need to find the determinant? Well, we'll need H first anyway. So we just copy this down in a more neat fashion, though, obviously. So that's the Hessian matrix. And then we need to find a determinant. So which is just negative 2y over x squared and then sine y minus cosine y minus 1 over x squared, and that's the determinant of H. We don't need to break all the brackets and all that, that's unnecessary. Part B gives us that S has one stationary point P, and we want to find what P is. So sine y, obviously all of the x's are greater than 0, and sine y is greater than 0 for y belongs to 0 pi unincluded. So this implies determinant of H is always less than 0, which implies P is a saddle point. And that's it for part B. Part C is just some basic algebra to find, to prove that the equation is true. So we know that the first derivatives are 0. So let's go ahead and use that knowledge to our advantage. I think we get alpha sine beta. That's wrong. I'm sorry. Should be using these up here. So that's cosine beta minus beta over alpha squared, which is 0. Which implies, we don't need implies right now. What are we doing? Delta z, delta y. Again, we put in the same stuff. Is equal to as alpha. Wait, is that cosine? Yeah, alpha cosine beta plus 1 over alpha, which is also 0. And just checking, I think I got this wrong. That should be a sine. And I think both of them have this 1 over alpha squared. So let's go ahead and do that. And here we have 1 over alpha squared is equal to negative cosine of beta. So obviously now we could say that sine beta over beta is equal to negative cosine of beta, which implies beta plus, ooh, is that a plus? Yeah, that's a plus. Beta plus tangent beta is 0. And that's it for part C. Very basic as well.